All right, so we're looking at radical expressions. Your radical is going to be, your square root, cube root, fourth root, fifth root, 100th root. I'm not saying you ever experience that, but, just saying that that's what it is, that would be your radical, you know. So here, when we look at the square root of x, if I want to write this square root as an exponent, and I'm pretty sure we'll get to that in our next section. I'm just giving you a heads up. It would be 1/2. Notice for your square root index, and I didn't write this here, that's the index of your radical. If there's nothing there, they assume there's a 2 there. So the square root is represented just by the radical itself, and that 2 is the index. You will not ever see a 2 there. They assume it's a 2 there when you see nothing. And so the exponent that represents that is 1/2. Exponent that represents the cube root is x to the 1/3, x to the 1/4. So whatever that index is, if you want to represent that as an exponent, it will be 1 over that number. All right, that's going to come into play shortly. All right. So what does this mean? If I have the square root of 64, you're asking yourself, what? So that's what you're asking yourself. What times itself twice gives me 64? And the answer is 8, because 8 times 8 is 64. All right. Same thing as if I had the cube root of 64. What times itself 3 times? So what times itself 3 times will give you 64? And that answer is going to be 4. That's 4 times 4 times 4 is equal to 64. And of course, that twice comes from your index. 3 times comes from this index as well. Any problems? Any problems? So, square root of 144. Let's go somewhere else. Let's do 121. Square root of 121 is 11, because 11 times 11 is 121. Well, the square root of negative 121, I have to be careful here. When you go to analyze what 2 numbers times itself twice, or not what 2 numbers, what number times itself twice will give you negative 11. Well, it's not negative 11, because negative 11 times negative 11 gives you positive 121. And of course, positive 11 times positive 11 will give you positive 121. So here, your answer is actually going to be not a real number. We may get into imaginary numbers. I need to look ahead, but right now, we are going to write not a real number. Now, let's say if I had negative square root of 121, this is fine because the negative is sitting on the outside. So that negative will still be on the outside once you apply the square root to 121. So that's going to be negative 11. So notice the difference between where the negatives are located in reference to the application of your square root. If it's under your radical, under your square root, then it's not a real number. But if it's in front of your square root, then it's fine to make that application. Now, if I had the cube root, let's say negative 8. Let's go positive 8 first. Cube root of positive 8. The answer is 2 because 2 times 2 times 2 is going to be positive 8. The cube root of negative 8 will be negative 2. Because negative 2 times negative 2 times negative 2 will be negative 8.
Professor,
Yep.
this is where I get confused at.
Mm-hmm.
I thought you said the -8 is not a real number.
All right, that's what I was about to get to. All right, so let me explain. So now, notice what we're doing here. We have the index that's an even number. So I didn't say cube root. I said, and it wasn't about the negative 8. It's about the application of the index of your radical. So here we have an even. We have this square root. So you ask yourself, what times itself twice will give me negative 121? So nothing can multiply times itself twice to give you a negative number because the negative times negative will give you positive. Here we're saying what times itself 3 times to give you a negative number. Well, here negative 2 times negative 2 will be a positive 2, but I still have a negative left. So that's why the negative 8 is a possibility. So that same thing holds true to anything that's even versus anything that's positive. So if I have the fourth root of 81, that's 3 because 3 times 3 times 3 times 3 is 81. Now the fourth root of negative 81 will be not a real number. Why? Because there is no real number that you can multiply to itself 4 times that will give you a negative number. Because negative 3 times negative 3 is positive 9. Negative 3 times negative 3 is positive 9. Those negatives cancel and gives you a positive 81 once again. So there's no number that you can multiply to itself 4 times to give you a negative number. Now let's go back to an odd option. So let's say if I have the fifth root of, let's go fifth root of 32. This is going to be 2 because 5 times, I said 5. 2 times itself 5 times is 32. Now the fifth root of negative 32 will be negative 2. Now once again, we're comparing, here we have an even index, not a real number. Here we have an odd index. We get a real number. Why? Because negative 2 times negative 2 times negative 2 times negative 2 times negative 2 will give you negative, I said it will give you negative 32. So here, that'll be a positive 4. Here, that'll be a positive 4, but then this will be negative 2 still. So 4 times 4 is 16, times negative 2 is negative 32. So it's all about whether you have an odd index versus an even index. So even Let me say this. All right, so what we're saying here is that the even index of a radical cannot take the root of a negative number without the result being imaginary. So then the other side of that is that an odd index of the radical can take the root of a negative number. And then that's also something you can play with in your calculator, plugging in values, seeing what can be taken the root of and what cannot. All right, questions. All right, let's go here. All right, so now when we get into the taking the root of variables, we're always going to want the positive representation, and that's where the absolute value comes into play. And I'll give you directions on what you will see or examples of what you will see when you wouldn't use it. But if I'm taking the nth root of x to the nth power, I'm going to look to use the absolute value of x, and I'll show you why in a second. But if n is odd, and that's when n is even, but if n is odd, then you just take the value that you get. You don't have to worry about it. All right, so why is this important, or why would that be the case? And that goes back to what we said initially. So if I have the square root, well, no, let me go here. 5 times 5 is 25. Negative 5 times negative 5 is also 25. So when I take the square root of 25, remember the question you have to ask yourself, what number times itself twice will give me 25? Well, the answer is 5, but it's also negative 5. Right? So what they're saying is that what we want is the positive representation, which is the 5. So when you take in the square root of x squared, to ensure that you get the positive representation, because remember, you could have thrown in 5 or negative 5. They want you to use the absolute value. Come on, man, scroll up. So if I have the fourth root of x to the fourth, I would use the absolute value. Now, if I have the cube root of x to the third, I'm just going to write x as a result. Because cube root and cube, going back to square root and square, fourth root and the fourth power, those, cancel each other out. Just like when we go back to our solving, if I have 5 divided by 5, those will cancel each other out, leaving us with x. It's the same thought process. The root and the power cancel each other out. And so that's what this was alluding to when you go back here. So the square root and the square cancel each other out, leaving you with just x. If it's even, then we want to use absolute value on it. Fourth root and the fourth power cancel each other out. We want to use absolute value on it. If I have the 101st root applied to the 101st power, they will cancel each other out and leave me with just x because it's odd. If I go to 200, and I'm just throwing just extreme values out here, I'm not saying you're going to ever see this, but because it's even, I need to use absolute value. Okay. Questions on that concept before we do a real example with that? If I have a plus b, square root of a plus b squared, once again, that square and square root cancels out. That will leave me with a plus b, but because I have variables, I need to use absolute value. Because I don't know what those variables are yet. But once I plug them in, I need to get that positive result.
Professor,
Yep.
I just want to recite something to make sure I got it.
Mm-hmm.
So you're saying the square root sign cancels out the 2.
Right. The
But the
power of 2, the square.
square root sign is automatically assumed to be square root.
Mm-hmm.
Okay. Thank you.
Mm-hmm. And then here, if I had the 13th root of a plus b to the 13th power, all I would write is a plus b. I don't need absolute value. And that's because of odd index. All right. So when would you not have to do that? Let's say the direction says simplify. And assume. All right, so this statement right here, assume all variables are positive real numbers. If they make that statement, then you do not need your absolute value signs. Because remember, the absolute value ensures that you're going to get a positive value. Just in case you forgot what absolute value does, if I have absolute value of 5, the answer is 5. If I have the absolute value of negative 5, the answer is still 5. Absolute value, once you apply the absolute value, it ensures that you get a positive result. But if we're going to assume all variables are positive, that means when I take the square root of x squared, all I have to do is write x because we are assuming all variables are positive. So once you start seeing that statement, you don't have to worry about writing absolute value. All right. Questions on that before we look to do a few examples? Just simplifying. All right, so if I have the square root, I want black, 81. All right, so 81, a to the eighth, b to the sixth, c squared. Take the square root of each one of them individually. Now, whether you write this out or not, this is how you should be processing what's going on. Square root of 81 is 9, because 9 times 9 gives me 81. Now here, remember I already told you before what the radical represents as far as an exponent is concerned is 1/2. So that 1/2 means you would divide each one of those powers by 2. So that's going to be a to the fourth, b to the third, and then c. That'll be your answer. All right, questions. All right, so the fifth root of 32, x to the 20th, y to the 15th. Do the same thing. So what times itself 5 times will give me 32? And that is 2. Now when we look at our exponents, we're going to divide it. Divide it by the number that's sitting out here. So 20 divided by 5 is 4. 15 divided by 5, and I didn't write that. Good enough. There you go. It's 3. Questions? Any questions? Excuse me. Do one more. Let's see what's a good one. All right, here, cube root of 27, x to the 21st power over 125, y to the 39th. So you take the cube root of each piece. All right, cube root of 27 is 3. 3 divided into the 21 will give you x to the 7th power. Cube root of 125 is 5. And then 3 goes into 39 13 times. Questions, questions, questions. All right, so that's 8-1. Let me see what is in 8-2. Hold on for 1 second. All right, so 8.2 is going to be cool for us because we've already talked about it. So it's just re-emphasizing what I was saying about the square root of x being x to the 1/2. So in other words, if I have 36 to the 1/2 power, you will recognize that still as the square root of 36, which is 6. So once again, this section is re-emphasizing this relationship. And also I'm going to put some in that power, but in that numerator. You'll see what I mean in a second. But basically, like I said, re-emphasizing that. Let's see if I have. It's a good one. I did that one. Yeah, that's good. So if I have 343 to the 1/3, that's the cube root of 343, which is just 7. 7 times 7 times 7 is 343. Guess we'll do one more. Let's go 625. 625 raised to the 1/4 power. And that'll just be 5. So problems or questions with that, like I said, let's just re-emphasize what we did last section. So the next step to that is to recognize that if it's a negative, I think we talked about that in this class, exponent rules. But if it's negative, then to make it positive, you drop it down bottom and then apply what we did in the previous exercises. So that'll just be 1/6. Or let's see, about 1,000 to the negative 1/3. That's 1/1,000 to the 1/3. Cube root of 1,000 is just 10, so that'll be 1/10. Also keep in mind, where do I want to go with this? If I have, let's go back to the negative 1/3. Say if I have negative 1,000 raised to the negative 1/3, those two negatives have nothing to do with each other. You know, I know when you talk about multiplication, negative to negative turns positive. Just re-emphasizing that this is not the multiplication process. This is being raised to a negative exponent. So I would drop that negative 1,000 down bottom to turn that 1/3 positive. And now I have the cube root of negative 1,000, which is negative 10, which is negative 1/10. Questions, questions, questions. Make sure we're okay. All right. The last new piece of this section is if you have something other than 1 in that numerator of your exponent. Always remember that the numerator is the power. The denominator, if I can spell it, is the root. So it doesn't matter which order you apply them in. Notice the way I have it set up. In the first one, you raise x to the a power and then apply the b root. In the second one, apply the b root, the bth root, yeah, to x and then raise it to the a power. It doesn't matter which order you do it in, just as long as you remember that the numerator is going to be your power, the denominator will be the root or the index of your radical. So if I have 8 to the 2/3 power, I can either take the cube root of 8 and then square it, or I can square 8 and then take the cube root of it. Either way, I will get the same result, just in different order. So the cube root of 8 is 2. 2 squared is 4. 8 squared is 64. Cube root of 64 is 4. So either way, you'll get the same result. Now, if you're not doing it with a calculator, it may be more beneficial to go one way versus the other way. You know, in this case, it was a small number. Let me see what is a good one for that. Let's say if I have 81. Let's go a little lower since I'm doing this in my head. Let's go a little lower. Yeah, let's do that one. All right, so let's say if I want to do the square root, not a square root, 49 to the 3/2, and I wanted to, you know, do it in my head instead of dealing with a calculator. I have the choice of doing the square root of 49 and then cubing that, or I can cube 49 and then take the square root of that. Now, I just showed you that it doesn't matter which way you go as long as you hold true to the fact that your numerator is your power, denominator is the index of your radical. So if I look at this first one, I can take the square root of 49, which is 7, and then 7 times itself 3 times would be 343. And so it's all about dealing with familiar numbers. If you're not going to have a calculator at your disposal, the order matters if you're dealing with, you know, if you want to go ahead and deal with familiar numbers. That's familiar to me. What's not familiar to me is multiplying 49 to itself 3 times. Off the top of my head, I do not know what 49 cubed is. But of course, if you have a calculator, it doesn't matter because you can throw it in the calculator. But if I'm doing this by myself, in my mind, this would not be the most beneficial route for me to go. And so that's when it matters. Other than that, you're still going to cube it. In other words, the third power, to take it to the third power, and you're going to take the square root of it. All right, questions on that before I put another one up. See if I can find another good one. Oh, that's a good one right there. Probably the last one we do. Oh, let's go here. All right. Looking at this one, -4 raised to the 3/2 power. Don't forget what we just finished mentioning. The index or the numerator is your power. Your denominator is your root. All right. So either way I do this, if I were to take the square root of -4 and then cube it, or -4 cubed and take the square root of that, we see what's going to happen for us. Anybody? When we look at the square root of a negative, it's going to be not a real number. And even in this one down here, if I decide to cube it first, that will give me a -64. And either way, my result will still be not a real number. Cannot take the square root of a negative without incorporating imaginary numbers. And remember, it's not just square root, but even root, any even root. All right. Questions. All right, so let's look at this one. Probably the last one, unless you guys want another one. Just let me know. But the fourth root, or 1/16 raised to the 1/4 power, minus 1/81 raised to the 1/2 power. So fourth root is of 16 is going to be 1/2. We're talking about how many times can what times itself 4 times will give you 16, and that will be 2. Then what times itself twice will give you 81, and that'll be 9. Square root of 81 is 9. And now we have regular fractions, so that means we need a common denominator, which would be 18 for us. Multiply top and bottom here by 9. Multiply top and bottom here by 2. It's 9/18 minus 2/18, 7/18. Questions? Any questions? All right. So that's 8-1 and 8-2, just dealing with these radicals and exponents. So as always, make sure you guys are trying this stuff out. And my door is always open for questions if you have them. Any questions before we close out today? All right. So if you guys are good, then I'm good. I will see you next week. Have a great weekend and be safe.
Yeah, good one, Professor Tucker.
You do the same, sir. I'll be looking for those emails.
Have a good one,
Hey,
Professor Tucker.
You do the same, sir.
like I said before, I'm gonna do the review
Mhm.
and see how I do. If I have a hard time with the review, I schedule a time with you via Zoom.
Okay, sounds good.
Thank you, Professor Tucker.
All right, man. You have a good one.
And to you.